Now, in the first lesson of light chapter, children, we had discussed some basics of reflection of light, reflection phenomena. You can see what do you mean by a reflection of light? The bouncing back of light. When a light strikes on a surface, what kind of a surface? For example, a mirror, well polished surface, well shining surface. When it incident, it reflect back. It reflect. Bouncing back of light is called reflection. And in the reflection phenomena, we have discussed on the very two important factors, children. Angle of incident. What is that angle of incident? Listen carefully, children. Angle of incident means incident ray. From where this ray is coming? From any source of light. Suppose a laser light. You have a laser light. You are striking the laser light on the surface of a mirror with some angle of I. It may be of any angle, children. This angle I, incident angle, is always in between the incident ray and the normal. The second point, when it strike incident on the surface of a mirror, it reflect back, it bounce back in the same medium and it changes direction. So here you can see the light will be reflected with the same angle as it is incident on the surface. For example, what I'm saying here, if suppose light incident with an angle of 30 degree to the point P here on the mirror after drawing a normal, then light is reflected back in this direction. So this angle R is also equal to the same angle 30 degree. And this explain in reflection of light, angle I is equal to angle R. Again, what is this R? Angle R is the reflected angle, reflected. And this is the angle between reflected ray and the normal. Remember, children, this angle made by the reflected ray with the normal. You can make this diagram by keeping the mirror in a vertical position, or you can also draw this diagram by keeping the mirror in the horizontal position. We have also discussed that this formula, law of reflection, I is equal to R, angle I is equal to R. Again, we have seen in the last lesson, children, image formation in case of a mirror. If you see there is an object in front of a mirror, we have placed an object, any object, children. Lights coming from that object strike on the face of the mirror, and after reflection, and you can see an image is formed, a virtual image is formed. Because at this point, children, these images are not meeting. Basically, after reflection, the rays are going in this direction. But if you produced it in the back direction, so it appears that they are meeting at this point, and that is a virtual image of the object. And here in this also you have to remember one point: the distance of object from the mirror is the same as the distance of the image. Hence, image is always formed at the same distance from the mirror as the object is from the mirror. So please remember this point. This type of questions come in exams. For example, if I say object is placed at a distance of 5 centimeter from the surface of mirror, and now the question is, what is the distance between object and image? What is the total distance between object and image? Anyone from ninth class? Distance between object and image. Yeah, it's 10, correct. And Jenny said it is 10, correct, children. So the total distance, because we know the image also formed at the back side of the mirror, 5 centimeter at a distance of 5 centimeter. The question is the distance between object and image. So 5 plus 5, that will give you 10 centimeter distance. We also discussed about children real and virtual images. What is a real image? When they when the rays actually intersect at a point. So at the point of intersection, image is formed that is called a real. Real image can be taken on the screen, but a virtual image formed in a case of a mirror, they are virtual, and virtual images cannot be traced on a piece of paper on a screen. So let us begin, children, our next topic. And for today's lesson, our topic is refraction of light. Please, children, pay attention. Refraction. The term refraction. Refraction means bending of a ray of light. You can see here. The waves change speed and direction when they pass from one medium to another medium. This effect is known as refraction, and it happens to light waves whenever they move from one medium to some another medium. Objects change their speed and direction when they travel from one medium to another medium. Here we are talking about a light, refraction in light, light coming from the sun, radiation coming from the sun, light coming from a laser light, light coming from a bulb. When these are allowed to pass through one medium to another medium, their speed change, their direction get changed. And this effect and this phenomena is called, children, refraction of light. In short, bending of ray of light when it passes from one medium to another medium. What do you mean by this one medium to another medium, children? Bending effect is always observed in two mediums, and these two mediums should be there should be a difference in the density. For example, if light is coming from air entering into water, from air to glass, or maybe from water to glass, or from glass to water, there are many combinations. So that is the meaning. When light moves from one optically medium, rare medium to some optically denser medium, it bends. Velocity change. And we are going to discuss velocity change means it can increase, it can decrease. We will discuss on this point. So first thing that, children, you have to remember, when light moves from air into glass, then light will slow down. You can put a question mark here, why the light slow down. Light will slow down. This causes it to change direction and it bends towards the normal. Please first note it down, that these 2 points. And the second point, when light moves from glass block into air, this is the reverse. In the first case, air into glass. Second case, glass into air, then it will speed up. This cause again change in direction away from the normal. Please make a note of this. Away from the normal towards the normal. I will show you this in our diagram also. But before that, I want to discuss some more points about refraction. Light bend. Here, children, when light moves from air into glass, it slowed down. Think about on this point. It slowed down. Means the speed of light reduced, get changed when it entered into a medium. Apart from air, if it entered into any other medium, it slowed down. You know what is the speed of a sound? 3 times 10 to the power 8 meter per second. 3 times 10 to the power 8 meter per second is the speed of light. See, it slowed down. In the previous chapter, children, please recall the concept of previous chapter of sound. In sound chapter, we have seen that sound speed is minimum in air and it increases when it moves or entered into a denser medium like a solid. Speed of sound is maximum in solid. But here, in case of a light, this is reverse. Light speed reduced in solid, but sound speed increases in solid. Please make a note of these 2 points. And children sometimes misuse means they wrongly write in exams. They use the concept of sound in light and light into sound. Sound speed increases in solids and speed of light reduces in solids. Please remember it. Okay, now children, let me uh, explain these the 2 points. It slow down, it bends towards the normal, and it bends toward away from the normal. What do you mean by this point, children? Look at this diagram. Here in this picture, what do we have? You can see that there is a glass, a material. Outside this surface, outside this surface, what do we have? Air. Means basically in a room, we have placed a piece of glass, a transparent material having certain thickness. This is in two-dimension picture here. A thickness, a width. And suppose light is coming from air. There is some source. Suppose let me write here. We have a laser light. Laser light is here at this point. From this point that the light, a beam or a source or a ray of light is strike at this point, at this point on the glass surface. I need to draw a normal. So I can write here that this angle will be the angle of I, incident angle. Then please children, what happens with this ray? When a ray of light strike at a point P on the first side of a glass, on the left hand side of a glass material, when it was, now listen carefully children, when it was in air, it was going in a straight path. But as soon as it strike at a point P, or as soon as it reach at the point P, it stop moving in the straight path. Now children, you can see here, instead of going in this instead of going in this direction, it changed its path. Where it is going? Where it is going? You can see it bends. Where? Towards the normal, children. This is the normal line. It bends towards the normal. In later classes, we will try to find out with what angle this will bend, how much it will bend. But basically, this angle is called again angle R, but this angle R has a different name, and this R is called angle of refraction. Angle of refraction, children. The same R we used in reflection phenomena, that is called the reflected angle. Here, in case of refraction, the same letter R is called angle of refraction. This phenomena is called, children, what? Refraction phenomena. It bends. Bending of ray of light. Why it bends? If someone asks you, why it bends? What happens with the ray? What happens with the electromagnetic waves? What happens with this visible light? What happens with the with this white light? Or what happens with this monochromatic light if I use that the light is coming from a laser light? Only one color. Its speed slow down. The answer is, children, due to the optical density of the glass, which is higher compared with the air. As soon as the light entered into this glass, the particle speed or the speed of sound, sorry, the speed of light reduced. And due to that, it bends towards the normal. Again, children, we have discussed this, the reflection at some this point, sorry, refraction at point P. Now the ray reached to the another point, another boundary of the glass, another boundary, the second side of the glass. Remember, this glass is having certain thickness. The light bend, refract, and now it strikes to the other point. Suppose this is the P prime, another point. What will be the angle of incidence and where I have to represent this one, children? Again, this ray, I will say again incident ray at point P prime, and now it is moving from where? It is going from glass to air, children. Remember, now it is going from glass. From P to P prime, the light has traveled for some seconds. P to P prime, it remains inside the glass with certain velocity, with reduced velocity. Now it is reached at the point P prime, it strikes there with some angle, and then it will go out. Light transmit. Transparent materials, they transmit the light. So light will come out, but where it will go? Are you with me, ninth class students? Are you paying attention? Ninth class boys, girls, Chuvila.
Yes, sir.
Please be attentive all the time. And now here, the ray is at point P prime, children. And the question is, in what direction it will go? Again, children, if I suppose if there is no air, then if we have a, let me enlarge this glass surface. If I keep it like this, the glass surface, so this ray will keep going in the straight direction. But that is not the case, because at this point we have glass surfaces ending, and now the light is entering into the air. Different density of the material. And now what will happen? When the ray of light moves from denser to air, it bends away from the normal. So you can see it bends away, children. It is bending away from the normal. Whatever the speed is reduced in the denser medium, it again increased in the when it entered into the air, and it will retain back the same speed if you have taken the case of speed of light, and that is 3 times 10 to the power 8 meter per second. So two things you have to remember. Let me write here. If the ray of light is moving from rarer to denser medium, the meaning of rarer and denser, you know that both are the relative terms. Rare medium can be a denser medium with respect to some other kind of medium. For example, if you take air and water, air will be considered as the rare medium, water will be considered as the denser medium. If you take an example of water and glass, in case of water and glass, water will be considered as the rare medium, glass will be considered as the denser medium, because there is a difference in the optical density of the both the material. So these are some few terms that you have to remember, children. Here, this water was a denser medium compared with the air. Now, in case of a water and glass combination, water is rare medium, glass is denser medium. So always you have to compare in with what respect we are taking it. So what I was telling you, children, when the ray of light moves from rare to denser medium, it always bends. Please make a note of it. Please note it down. It bends towards the north, towards the north, and reverse. If it is moving from denser to rare, it bends away from the north, away from the north. Yes, Kim. The same activity you can also try to perform at home, children. You need a rectangular glass block. You need a rectangular glass block, children, and you need a laser light. You need a laser light, and try to strike the laser light on the one face of a glass, that glass surface, and then you can see. Keep the light of your room off. Then you will observe the light bend. When it entered from air into the glass, it bends. And again, the same kind of path you will observe if you do this activity at your home, children. These are the experimentally proven result, and this will happen, children. That is the phenomena, refraction of light. I want to discuss one more topic, children, then we will end our class. The last topic for today, this is refractive index. Now, in the previous topic that we have discussed about light bend or it slowed down when it entered from one medium to another medium. And the reason I have given you that because its speed slowed down, it slowed down. And now the question is why it slowed down? Why it slowed down, children? Now have a look on this slide, children. What is written here? The speed of light in a substance is different than the speed of light in vacuum. Yes, we know. For example, light travels at approximately this value in glass, while it travels with 3 times 10 to the power 8 meter per second in vacuum or in air. Now we have another term here, the refractive index. What is this refractive index, children? What role it play in physics, in our life also? Refractive index is represented by the letter small n. Sometimes in grade 11 and 12 you will find the refractive index is also represented by the letter mu, 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 o, mu. Okay, so here in grade 9 I am going to use letter n for representing the refractive index. There is a mathematical equation for refractive index. This is given by n equal to speed of light, L-I-Z-H-T, in vacuum divided by the speed of light in some substance, in some medium. It may be in the water, it may be in air, it may be in a glass, it may be in a diamond. There are different kind of materials available. So n equal to speed of light in vacuum divided by the speed of light in a substance. Now, if you have seen carefully, this term, the speed of light in vacuum, it is a constant term. So refractive index is basically inverse proportional with the speed of light in medium, in certain medium. So basically, what is this n here? Greater the value of n, more optically, it is a denser medium. Means n, if n is large, the refractive index of material is large. Means if its optical density is large, then in that particular medium, the speed of sound, sorry, not the sound, but the speed of light will reduce. More and more is the value of n, the speed of light reduced. So there is another answer. Why the speed slow down? Due to the refractive index of the material. Refractive index will help us to find out how much is the speed of light is reduced in that particular medium. If we know the value of n, if I know the value of refractive index, I can calculate that what is the speed of light while it passing through the glass surface, while it passing through water, while it's passing through any other in a kerosene oils, in oil, or maybe in a diamond. There are different optically denser mediums. Now, let us take one example, children, then we will end our class. Work at example number 1. In this example number 1, speed of light in vacuum is there. Speed of light in water is 2.25 10 to the power 8 meter per second. What is the refractive index of water? You have to calculate refractive index. You have to calculate the refractive index, children. Refractive index equation is this one. You have to use what is the value of speed of light 3 times 10 to the power 8 divided by the speed of light in a substance is given how much? 2.25 10 to the power 8. This term will cancel out. So now we have 3 divided by 2.25. Please someone do this calculation in your mobile phone. 3 divided by 2.25.
It's equals to 1.33, sir.
1.33 something. Okay, so yeah, you can see here in the solution the answer when you divide it. So this 1.33 is the refractive index of what? Water. And you have to memorize also this value, refractive index. Suppose now let us do this question in a different way. Suppose I will say that the refractive index of water is given 1.3 and you have to calculate. Suppose this value is not given, you need to calculate what is the speed of light in water. So how will you do? Again, the same equation, n equal to c upon v. What is this v? V is the speed of light in that particular medium. I need to calculate v. This v equal to 3 times power 8 divided by n. And what is n? N is 1.3. Now please someone divide 3 divided by this value. 3 divided by 1.33, and I hope that you will get the same value this way. Please someone divide.
2.25.
2.25 again, 10 to the power 8. So that is meter per second. And remember children, refractive index, it is a ratio, speed of light in vacuum divided by speed of light in a medium. So unit will be cancelled out. So it's just a number. It's a number. It's a pure number. That's for the day, children.